Welcome to the third tutorial on AMIRIS. This video covers input parameters and their modification. Open your AMIRIS Python environment. In our case, via conda activate AMIRIS env. Then start Spine Toolbox. Once it has opened, open the Toolbox AMIRIS Demo project. In the center pane, click on the scenario item and then to the right, double-click the scenario YAML to open the associated file. The scenario YAML is the config file to define an AMIRIS simulation. It consists of at least 4 sections. Schema defines the simulation's capabilities. General properties control overall simulation parameters. Agents is a list of all entities in your simulation and their parameters, and contracts define how and when the agents interact with each other. In variables, optional parameterization templates can be stored. Let's first have a look at the General Properties section. The most important part there is simulation. Its first parameter, start time, defines the first time within your simulation. Accordingly, stop time tells the last simulated time. Random seed controls the overall seed for pseudo-random number generation in the simulation. Ignore the other parameters run ID and output for now. Expanding the agents, you see a list. Each item represents an agent in the simulation. This scenario comprises about 50 agents. Some of them share the same type, but they are all individual agents that may differ in their attributes. Each agent has at least a type and ID specification. Its type relates to the Java class name that defines the agent's capabilities. ID is a 4-byte positive integer unique to each agent. No two agents may have the same ID within a simulation. All message exchange is coordinated using this ID. Keep this in mind for the contract definitions later on. Configuration parameters specific to each agent can be defined below the keyword attributes. The inner structure of these attributes depends on the type of agent. It can be a plain map of keys to values or a more complex hierarchy like in this case. Here, the fuel prices item resembles a list of items, each specifying a fuel type, associated price and conversion factor. However, attributes can also take a simpler structure, as in the case of the energy exchange. Here, only 2 key value pairs are required. Some agents, like the system operator trader, do not require any attributes at all. To keep this scenario YAML file tidied up, the contract definitions are not directly part of it. Instead, we use the include command to load content from other YAML files into the scenario. To see how this works, open the Toolbox AMIRIS Demo folder and navigate to Data. Open the Germany 2019 scenario folder. There you see the scenario file we are editing right now. You can find the subfolder's name Contracts also in the string of the scenario's include command. This string tells which files to include relative to the location of the scenario file. Opening such a contract definition file, you can see the contract section. Only this part of the file is imported into the scenario, as specified by the second string of the include command. The contract section contains a list of contracts. Each contract comprises 5 elements. Sender ID refers to the unique ID of the agent that will send the message. Likewise, receiver ID identifies the agent receiving the message. Product name defines the content of the message. The first time a message is sent in the simulation is given by first delivery time. Finally, delivery interval in steps tells how many seconds pass until another message of that type is sent. Similar to the contracts, the schema is also not a direct part of the scenario file. It is, again, imported using the include command, but this time referring to a specific file called Schema YAML. It is located in the same folder as the scenario file. Opening the schema file, you find the definitions for each type of agent, the attributes they require, and also defining their structure, and the products they can emit in their messages. You will find the product's name from the schema to match the product name in the contract definitions. The sending agent defines the available products. Now, you might have noticed earlier that in the definition of the fuels markets attributes, the price value for some items took floating point numbers and for other items was represented by a file path string. Navigate to your scenario folder and enter the time series subfolder. You will find the file mentioned in the string there. Open it to see for its structure. Its 2 columns are separated by a semicolon. The first column is a timestamp that defines at which point in time the floating point value in the second column shall be valid. Notice the underscore between date and time of day parts of the timestamp. Interpretation of time series varies in AMIRIS. Most agents, however, interpolate values at missing timestamps. This grants high flexibility when defining time series, since one may use any and even irregular timestamp entries. If a time series shall take a constant value, you need not define a new time series file that has but one entry. Simply replace the file path string with the desired constant value, as it is the case for the nuclear and lignite fuel prices here. You can find further and detailed information on AMIRIS input parameters in our wiki. Browse to our GitLab repository and click on the wiki badge. The Model Classes section highlights each type of agent and their hierarchy. Check out the renewable plant operator, for example, a child of plant operator. Besides other descriptions, there is the input file section. Input from file. It describes input parameters used in the scenario YAML for that type of agent. In this case, set and energy carrier, for example, but also other input types exist. Looking at the scenario definition, the agent with ID 53 has these input parameters. It does not define a set parameter, however, as this parameter is optional. but it features the additional yield profile, which is a parameter for the child class variable renewable operator. With all that background, let us go back to the Spine toolbox. Open the scenario file. Navigate to the carbon market agent and replace the time series for the CO2 prices with any value you like, for example 100 euros per ton. Then save the file and rerun the workflow. See in our next video to learn about the AMIRIS outputs and how to inspect the results from workflow executions.